I see infrastructure and cloud fund farms for a living, which means I think about this stuff the way an ops person thinks about it, not the way someone hoping for a lucky drop thinks about it. When you're managing dozens of identities across dozens of machines, the question isn't will something eventually go wrong? It's when something goes wrong, how much do I lose? That question is exactly what wallet signing isolation is trying to answer, and it's worth walking through slowly because most farmers set it up backwards or don't set it up at all. Start with the actual failure mode because it matters. Most wallet losses aren't cryptographic breaks. Nobody's factoring your private key. What actually happens is that the environment around the key gets compromised, a browser extension gets swapped for a malicious one, a fake update prompt gets clicked, a clipboard hijacker sits quietly in the background, or some completely unrelated dev tool pulls in a bad npm package that happens to be sitting on the same laptop you use for everything else. If you're running one wallet, that's a bad day. If you're running dozens across multiple chains for airdrop farming, that same weakness is a single point of failure for the entire operation, and the more wallets you accumulate, the more that single point of failure is worth to whoever finds it. A dedicated signing device solves that by doing exactly one job. It's a machine, or a strictly isolated virtual machine, that holds keys and signs transactions and does nothing else. It doesn't browse the open internet, it doesn't run Discord, it doesn't have your email client sitting open in another tab. It never touches the anti-detect browser profiles you use to click around dApps and claim pages. Everything else in the stack, the proxies, the browser fingerprint management, the RPC calls, the actual interaction with a protocol's website, happens on a completely separate machine, and that machine only ever talks to the signer through a narrow channel that you set up on purpose. Think about what that buys you in blast radius terms. If your fingerprinted browsing machine gets hit with a malicious script through some compromised that front end, the worst case is that machine's browsing session, its cookies, maybe the proxy credentials tied to that one identity. It is not your keys because your keys were never there. Compare that to the 40 wallet laptop from the opening example, where one bad extension update reaches every single key you've ever generated because they all live in the same browser profile on the same machine. Separating signing from browsing turns a catastrophic farm-ending event into a contained, recoverable one. It's worth being specific about the threats instead of just waving at security as a vague good, because specificity is what tells you which defense actually matters. Malicious or Trojanized browser extensions are one of the biggest ones, a wallet extension update, or a convincing fake of one that quietly exfiltrates seed phrases or auto-approves transactions in the background. Clipboard and address swap malware is another. Software that sits and watches your clipboard and swaps a copied wallet address for the attacker's address in the half second between you copying it and pasting it into a send field, so you send funds to an address that looks right in your head but was never what you actually copied. Then there's supply chain compromise sitting in software that has nothing to do with your wallet at all. A dev tool, an unrelated browser extension, even a node package with a post-install script that quietly scans the file system for keystore files or anything that looks like a seed phrase. Phishing pages that mimic a wallet connect flow are their own category too. A page that looks exactly like a legitimate claim site and gets you to sign a transaction that doesn't actually do what the interface tells you it's doing. And then there's the boring physical one, physical or remote access to a machine that's shared with other activity, other users, or left exposed through some remote desktop tool you set up once and forgot about. None of those require breaking cryptography. Every single one of them requires getting code running in the same environment your keys live in, or tricking you into signing something you didn't mean to sign. A dedicated machine doesn't magically defeat phishing. Someone can still trick you into approving a bad transaction on a signing device just as easily as anywhere else, but it removes the extension and clipboard categories almost entirely, and it meaningfully shrinks the surface for the supply chain and remote access categories too, because there's simply less software running in that environment for anything to hide inside. There's a spectrum of how far you take this, and where you land depends honestly on how much value and how many wallets you're actually managing, not on some fixed rule. The top tier is an air-gapped hardware wallet, which is the standard for anything holding meaningful value. The seed phrase never touches an internet-connected device at any point. Rebuild the transaction on a connected machine, move it over to the hardware wallet to be signed, whether that's over USB, a QR code, or an SD card, depending on the device, and then move the signed transaction back to the connected machine to broadcast it. The key itself is never in the same room, digitally speaking, as anything that can reach the internet, and if some of your farmed wallets are accumulating real value over time, those are the ones that should eventually graduate up to this tier. One step down from that is a separate physical machine that's either always offline or sitting on a lockdown network. This doesn't need to be fancy. A cheap mini PC or an old laptop works fine, wipe clean, minimal OS install, nothing on it beyond what's strictly needed to install a wallet extension once. It stays fully air-gapped with transactions moved by USB, or is connected only through a controlled connection you're actually watching, used solely to broadcast transactions that were already signed elsewhere. It's a step down in rigor from full air-gapping, but a big step up from doing everything on your main machine. The setup I see most often in active farming is a dedicated virtual machine, isolated from the rest of the farming environment, because full air gapping gets impractical fast when you're signing dozens of transactions a day across dozens of wallets. That VM gets its own disk, its own network route, usually a fixed monitored connection rather than the rotating proxy pool you use for browser fingerprinting, and nothing installed on it except the wallet software itself. Snapshots let you roll it back to a known clean state on a schedule, which matters because it means even if something did sneak in, it doesn't get to persist. That VM never runs the anti-detect browser profiles, never touches the RPC endpoints your farming browser uses for general dApp interaction, and doesn't share clipboard or folders with the host machine unless you open that link deliberately and close it again immediately after. Whichever tier you land on, the common thread is that the separation is structural, is built into how the machines are set up, not something you're maintaining through personal discipline. I'll just be careful is not a security architecture, it's a hope. And hopes don't survive contact with a fake update prompt at 2 in the morning when you're tired and clicking through claims on autopilot. The practical friction is that you still need to actually interact with dApp interfaces somewhere, connect the wallet, approve a transaction, click through a claim page, and that has to happen on your farming machine with its own fingerprint and proxy setup, not on the signer itself. One common pattern is wallet connect style relaying, where the dApp session lives on the browsing machine, but the actual signing prompt gets relayed to a separate device, a phone, a hardware wallet, or a signing VM for approval. The relay step is also your last checkpoint because you're reading the actual transaction details on the signing side right before you approve, which catches a lot of mislabeled or outright malicious transactions before they go through. Another pattern, more common with fully air-gapped setups, is manual transaction transfer, where the unsigned transaction gets exported as a file or a QR code, physically moved over to the signer, signed there, and then the signed transaction gets moved back and broadcast from the connected machine. It's slower, there's real friction in it, but there is never a live network path between the two environments at any point, which is the entire point. A third pattern, more infrastructure heavy, is a signing daemon running on an isolated VM that only accepts requests from one specific authenticated local process, which is what farmers running semi-automated multi-wallet workflows tend to reach for once wallet count actually justifies the extra maintenance. It's worth being clear that signing isolation solves a completely different problem than proxy hygiene or browser fingerprinting, and mixing those two up is a mistake I see a lot. Proxies and anti-detect browser setups exist to stop wallets from being clustered together by chain analysis, correlated by IP address, shared cookies, canvas fingerprints, or timing patterns, and then flagged as civil activity by a project running eligibility screening on an airdrop. That's a detection problem, and it lives entirely on the browsing and network side of the stack. A dedicated signing device isn't solving a detection problem at all. It's solving a theft problem. You can have flawless proxy rotation and perfect browser fingerprint separation across 50 wallets and still lose every one of them the same afternoon if the one machine holding all 50 keys gets hit by a bad extension update. I've seen farmers pour real effort into residential proxy rotation and careful browser profile separation, genuinely good ops on that side, and then store 40 seed phrases in a plain text file sitting on the same laptop they use to install random Chrome extensions on a whim. That's not a small gap. That's the whole operation resting on the weakest link in the chain. If you're farming across enough wallets that keeping track of seed phrases manually is starting to feel unwieldy, that's usually the actual signal that it's time to move signing off your general purpose machine, not a signal to build a more elaborate spreadsheet or a better password manager entry. The unwieldiness is the warning, not the problem to be solved on its own terms. It's also worth being honest about what none of this protects you from. A dedicated signing device does nothing if you approve a malicious transaction without reading what you're actually signing, and blind signing, approving a transaction hash without ever seeing its decoded contents, defeats the entire point of isolation no matter how many air gaps you've built around the machine. It doesn't protect you from a contract behaving one way in its verified source code and a different way in what actually executes on chain, though a hardware wallet with clear transaction display at least gives you a better chance of catching some of that before you sign. And none of it does anything about Sybil detection, address clustering, or airdrop eligibility screening, because those are separate problems handled by separate parts of the stack, the proxy and fingerprint side, not the signing side. Isolation reduces the number of ways your keys can be taken out from under you without your knowledge. It does not reduce the amount of attention you need to pay to what's actually in front of you before you click approve, and no setup, however air-gapped, replaces reading the transaction. I found these the boring typical way and write up what actually qualifies. The full guides and the tools I trust are at airdropfarming.org, full written guides and tested tooltips at airdropfarming.org, and if this kind of thing is useful, go ahead and subscribe.